Let's talk about the chemistry of nitrogen, specifically that of its oxoacids and its oxides. Well, this is nitrous acid. It's very difficult to form because it can easily dissociate. The only way of forming it is by adding sodium nitrite to hydrochloric acid under 10 Celsius, and then we will get nitrous acid alongside hydrochloric acid. If we increase the temperature above 10 Celsius, nitrous acid will decompose into nitric acid, nitrous oxide, gas, and water. And the nitrous oxide will react with oxygen to form the brown color nitrogen dioxide gas. So if we were to have a solution of nitrous acid just exposed to air and about 10 Celsius, it will first evolve this fume which is transparent, and this fume will react with oxygen to form the brown color gas. So it's a nice phenomenon. Yeah. Now we go on to nitric acid. Nitric acid is it is stable, but it can photodissociate into the brown color nitrogen dioxide gas, oxygen, and water. Basically, nonmetals react with concentrated nitric acid to form the respective nonmetal acid, nitrogen dioxide, and water. So with sulfur it is sulfuric acid, phosphorus phosphoric acid, carbon carbon dioxide, and water. Carbonic acid is very unstable, so it decomposes into carbon dioxide and water. But with metals is different. For example, as we discussed earlier, with dilute nitric acid, magnesium will form magnesium nitrate and hydrogen gas, while with concentrated one it will still form magnesium nitrate but it will form, instead of hydrogen, it will form nitrogen dioxide and water. There's an exception with copper, however, in which even with dilute nitric acid it will form nitrogen dioxide and water. Then we'll move on to the oxoacids of nitrogen. We discussed the oxoacids earlier, and they look like, and these are what they look like. They have a very nice diversity, and you'll be talking about their reactions now. You see, this is nitrous oxide. It has a lone electron. It has like just this dangerous, like just lone electron, like it's a very potent one, and it makes it very unstable, so that when it's cooled, NO, it dimerizes to form this compound. Actually, NO2, nitrogen dioxide, can do that also. When it is cool, nitrogen dioxide is always in this equilibrium with N2O4, which is colorless, and when it cools, when the temperature cools down, the forward reaction is favored. And nitrous oxide and nitrogen dioxide can form our good old nitrogen sesquioxide, which is light blue in color. Nitrogen sesquioxide will react with water to form nitric acid, while nitrogen dioxide will react with water to form nitrous acid and nitric acid. This is a disproportionation reaction because the nitrogen gets both oxidized and reduced.